this is Calculus 12, Chapter 4.4. We're going to be looking at modeling and optimization. So essentially, word problems. Here's the basic steps that you can take to solve your problems. Determine if it's a min or max problem. Okay, there's a lot of synonyms for min and max, so be careful. If you're given a formula, you can use it. Make sure the formula has the same units as the question. Otherwise, you'll need to do some conversions. If you're making your own function, check the units, match the problem, and make a drawing if possible. And here's another hint. Make sure the variable is about what the question is asking for. If there's only one type of question. Okay, so this is not always possible if the question has multiple parts. And lastly, determine if the answers are in the domain or are valid. Okay, so usually if you're answering something about length, time, you can't have negative values for those, so those would be invalid. Okay, we're going to do a few questions.
This is important.
You can't use these as templates. There's thousands of ways to form questions, so you can use them to see how things are set up, but don't take them verbatim. You have to adjust to what the questions are asking for. Okay, let's look at the first question, page 214, number 10. A 216 square meter rectangular p-patch is divided into two, so you need to determine dimensions of the outer fence and the amount of fencing. Okay, you need to decide what's going to be your variable. So we could have this length as x, this length as x. It's really up to you. But make sure you label things properly. So this is going to be x, this is going to be x, this is going to be x. For area, we have length times width. So since this is the area, we take this length and divide it into 216. Okay, so our area is x times 216 over x. These cancel out and we're left with 216. That matches the problem. The perimeter is the amount of fencing. So we have x, x, x. So this is 3x. And we have to add 2 times this length. 2 times 216 over x. And if you want to simplify that, we get 3x plus 432 over x. So come up with your formulas first. Our domain is x is greater than 0 because we're not permitted to have negative lengths. Okay, we want to minimize the amount of fencing, the perimeter. So we need to find critical points of p of x. So the derivative, p prime of x, equals, that's just 3. And this is 432 x to the negative 1. So we actually have minus 1. And 432 over x squared. So we want p prime of x equal to 0. So that's 3 minus 432 over x squared. And solving this, we get 3x squared equals 432. X equals plus or minus square root. 432 divided by 3 is 144. So we have plus or minus 12. But NPV, x equals negative 12. Can't have negative links. Okay, this is not so bad. We could do the second derivative. And it's negative 2, 432 over x cubed. And this should be a plus sign because we have minus and the exponent is negative 2. Okay, so answer is x equals 12. We can do the second derivative, p of 12 equals, it's positive. So concave up, and x equals 12 is a minimum. Okay, if you wanted to do the first derivative test, you could do that as well. We need to do p prime of 11, and that's 3 minus 432 over 121. Okay, so that's smaller than this, so that means this number is going to be bigger than 3. So this is less than 0. P prime of 13 equals 3 minus 432 over 169. This is bigger than 144, so this is going to be smaller than 3. So this is going to be greater than 0. And that shows the minimum. Okay, finding x does not mean we're done. We have to answer the question. So we need to plug it back into the formulas. So patch is 12 by 216 over 12. That simplifies to 12 meters by 18 meters. Don't forget the units in your answer. Fencing is 3 times 12 plus 2 times 18. That gives us 36 plus 36, 72 meters. Next example, cardboard box. Page 214, number 18. The piece of cardboard is 10 inches by 15 inches. Okay, so we draw the 10 inches by 15 inches, but we're cutting a corner out. So that's x, x. Here's another x. Okay, so this is 7.5 minus x. Okay, because that's half of 15. This is 7.5, this is 7.5, and both of them we're subtracting an x. Okay, so A, our volume, based on x, is x, 10 minus 2x. So it's 10, but we take off an x there and an x there. And then we have 7.5 minus x. So you do have to expand this because it's easier to take the derivative. If we don't expand this, you're going to need to use the product rule. So 2x times x, that gives us 2x cubed. We have 15x, another 10x, so that's 25x, but they're negative. And then we're multiplying by x, so x squared. And then 7.5 times 10, that's 75, and then we're multiplying by x. Okay, part B is asking for the domain. And we can't have any of these be negative. So this is 2, 5 minus x. So x can't be bigger than 5 here. And x can't be bigger than 7.5, but we take the most restrictive. So domain 0 to 5. Okay, part C is just asking to do it on your calculator. And we get this value, and we get this value for the volume. Part D, we're going to find the critical points and do it algebraically. So the volume, the derivative, is 2 times 3x squared minus 25 times 2x plus 75. Let's simplify this. This is 6x squared minus 50x plus 75. This is not going to factor nicely, so we'll just use the quadratic formula. X equals negative b, so that's 50, plus or minus square root b squared, that's 2500, minus 4ac, all over 2a, equals 50 plus or minus square root 700 over 12, and that's going to be roughly 1.962, which matches that answer. And this should be meters. And I believe the question is asking for the height of the box. And our second answer is 6.371. And this is an NPV because we determined the domain to be 0 to 5. So this is a polynomial. We'll just do a second derivative test. V double prime x equals 6 times 2x minus 50. Simplify that to 12x minus 50. Now we need to substitute our value, 1.962. 12 times 1.962 minus 50. This is less than 0 because 12 times 2 is 24. Minus 50 is going to be less than 0. So 1.962 is a max. Okay, the next problem is for business. We have our cost function, our revenue function, and our profit function. Profit can be defined in terms of cost and revenue. We have the marginal functions as well, which means the first derivative. When we want to maximize profit, this happens when the derivative of the profit equals 0. So we have r prime x minus c prime x. The other one is when r prime of x equals c prime of x. And we still need to do derivative tests to show that it's a max. Okay, minimize average cost theorem. We went over this before. We use CX over X. And to find the minimum average cost, if it exists, again, need derivative tests to show min. Okay, so you need to use the derivative test on that. Let's look at an example. Number 52. cx equals x cubed minus 20x squared plus 20,000x. Minimize the cost per unit, and this time we'll just assign a letter to this. U of x equals cx over x. So u x equals x squared minus 20x plus 20,000. Then the derivative of this is 2x minus 20. So we want u prime x equal to 0. So 2x equals 20. So x equals 10. It's not hard to take the second derivative. So let's do that. U double prime of x equals 2. So this is concave up for the whole function. And x equals 10 is a min. Now, this next step is not required, but I'm showing you what you would have to do if you needed it. Not required. If you needed the average cost, we need to plug it back into u. So we have 100. 10 squared is 100. Minus 20 times 10, that's 200. Plus 20,000. So the average cost is 19,900 per unit. Next question. Number 20. Jane is 2 miles offshore in a boat, wishes to reach the coastal village 6 miles down a straight shoreline from the point nearest the boat. She can row at 2 miles per hour and can walk at 5 miles per hour. Where should she land her boat to reach the village in the least amount of time? Okay, so we need to draw this. Okay, so the only variable we have here is this distance. And we need some formulas. Distance equals velocity times time, and time equals distance divided by velocity, doing some algebra. We are looking for time, so we should represent all our functions in terms of time. Time is going to be t of x, and the time, we need to split it up in the row time and the walk time. So the row time, since this is 2, this is x, this is square root x squared plus 2 squared. So we have square root x squared plus 4, and we're dividing that by 2. So not only is it 2 miles, it's 2 miles per hour. So we're doing the distance divided by the velocity. Plus, this is going to be 6 minus x, and that's at 5 miles per hour. So row time, and this is our walk time. We need to minimize this, so we need to take the derivative. T prime of x equals. It's best to think of this as x plus 4 to the power of a half. You can use the chain rule. So we're going to take the derivative of this. That's 2x over 2 times the square root x squared plus 4. And we need to multiply by another 2. And here, our derivative is negative 1/5. This does not factor into the derivative. Okay, that looks pretty complicated, but t prime of x equals 0 equals 2x over 4 square root x squared plus 4 minus 1/5. Okay, so we move this to the other side. We get 1/5 equals x over 2 square root x squared plus 4. Some more work. We get 2 square root x squared plus 4 over 5 equals x. Okay, we want to move everything but the square root to one side. So we have square root x squared plus 4 equals 5 over 2x. Now we can square both sides. That means we get x squared plus 4 equals 25 over 4x squared. Looks hard, but we just keep doing one step at a time. So we want all the x squareds over to one side. I suggest the right-hand side because this value is bigger than 1. So we have 4 equals, we're taking away 4, so that's 21 over 4x squared. That gives us x squared equals 16 over 21. X equals plus or minus 4 over root 21. Okay, but negative 4 over root 21 is NPV. Okay, I said to avoid the second derivative if our first derivative has a quotient in it, which it does. It's this, and it's not a nice quotient. I will show you the calculations, but you should just do a first derivative test. So this equals 2, 4 square root x squared plus 4 minus 2x, 4, 2x, 2 square root x squared plus 4 over 16 x squared plus 4, and this equals 16. We need to have a common denominator for these two to combine it. We're going to multiply this by square root x squared plus 4 over square root x squared plus 4. So that gives us 16x squared plus 4 minus 16x squared all over 32 x squared plus 4 to the power of 3 over 2. And these 16x squareds cancel out, so it's a little bit easier. This leaves us with 64 over 32 x squared plus 4 to the power of 3 over 2. That simplifies to 2 over x squared plus 4 to the power of 3 over 2. Okay, and then you'd have to do t double prime of square root 16 over 21. We can look at this and we just know that it's positive. So concave up and square root 16 over 21 is a minimum. And we're going to answer the question, chain must row square root 16 over 21 miles towards the village. Okay, if we look at the first derivative test, we need to do t prime of 0. That equals 0 minus 1/5. That's negative 1/5. And that's less than 0. t prime of 1 equals 2 over 4 root 5 minus 1 over 5. We need to have entire radicals. So this simplifies to 1 over 2, so we need to bring the 2 inside. This is 1 over root 20 minus, this needs to be converted to a radical, so this is 25. And this is greater than 0. And again, using these two statements, so it's a minimum. Okay, when we're going from decreasing to increasing, that's a minimum. And that completes this lesson.